Okay, good morning, good afternoon, good evening. This video won't be that long. I'm sure we can just briefly just remind one another on how to find some limits here, maybe another question or two, so that they shouldn't just bypass like that. So we have the question which says evaluate the following limits. So how do we evaluate limits? So what is a limit first of all? So we are looking at it in a context that, for example, if let's say for example I have a function f of x to be equals to 2x plus 3. This is a function. Obviously, we know that if this is a function, then there are two kinds of sets forming up this function. The function, or maybe the set of a domain and the set of the range. So I can have the domain set. Maybe I can say x is 1, x is 2, x is 3. These are the values of x. And I can have the range set. Maybe these are values of y. So what is happening here is that if I have x equals to 1, I insert 1 in there. Obviously, what am I going to have in the value of y? 1 in there to be 2 times 1 plus that should be 5. If let's say x is equal to 2, what will be the value of y? So this is the 4 plus 3, which is a 7. If let's say x is equals to 3, what is the value of y? This is 6 plus 3, which is a 9. This is how basically we are going to have our sets. So when you look at the information of limits, we are looking at it in such a way that we have values of x and we have values of y. So the limits we're talking about are y values. So this is where x is basically approaching these values here. So for example here, in this function, if I say what is the limit as x approaches 1 in the function f of x, this is my function f of x. So we're simply saying that what is going to happen to this f of x if x draw closer and closer to 1. That's the interpretation which we have here. What is going to happen to the function f of x if x draws nearer and nearer to 1? So if x is drawing nearer and nearer to 1, it means the whole function f of x will draw nearer and nearer to what? To 5. So it means as x approaches 1, the function will draw closer to what? To 5. So 5 in this case is the limit. So if I'm looking for the limit as x approaches 2 of f of x, in this case, then that limit is equal to what? 7. The limit as x approaches 3 in the function f of x, that limit is equal to what? A 9. That's what we need. So basically when you look at limits, we are looking at it, say, as x draws nearer to this, what value are we going to have? So basically in this case, in an easy context, we are just simply saying that the limit, in simple terms, we are simply saying that the limit as x approaches a in the function f of x is just basically the evaluation f of a. I'm sure we know how to evaluate functions. So we're just inserting a into the function f of x. X approaches 1 in f of x, we're just setting x equal to 1 in the function to have 5. So x equal to 1 in the function, then we have 5. That is the limit. But basically, it's not every time that the f of a can be the limit, because there are some cases whereby the limit does not exist, or maybe the limit tends to bring in an indeterminate form of limit. So in this case, we are simply saying that something to take note of. Take note. If, number 1, the limit as x approaches a of f of x is equals to 0 over 0, this should never be your solution. This is an indeterminate form. This is an indeterminate form of limits. So what do I need to do when I have such a case? Then simplify your function. So we need to simplify our function for the limit to exist. Then simplify your function for the limit to exist. That's what we are simply having there. So in a situation whereby we have the limit as x approaches a of f of x, and we have the answer to be 0 over c, then the limit is basically a 0. It exists, the answer is 0. But if we have a c over 0, then the answer is basically does not exist. Does not exist. But it can sometimes exist when other things are simply, sometimes it can be exist depending on a certain function. Maybe it can be to positive infinity or negative infinity in some cases. But when it's just something which is direct, we are simply saying the limit does not exist. So now with this information, now let's go back to our function. This is just something which is a recap, just a base of what limits are. So we have limits to a point where we're simply saying x approaching a, and we have limits to infinity. X is approaching either negative infinity or positive infinity. So how do we solve function when x is approaching a point and when x is approaching infinity? These are the two questions which we have here. So we'll start with infinity. So we'll start with infinity. So when it comes to limit at infinity, take note of the following. Number one, the limit as x approaches infinity of x power n, is answer is always equals to positive infinity. Number two, the limit as x approaches negative infinity of x power n is always equal to two cases. It can either be positive infinity or it can either be negative infinity. How? It will be positive infinity if n is even. It is negative infinity if n is odd. That's what we have as a second rule there under limits to infinity. And the third we can have is when we're talking about the limit as x approaches infinity of, let's say, c over x power n. This is basically equal to a 0. For now, I think with these three, they'll basically help us to find what we are looking for. So in determinant forms especially, your solution should never be the solution should never be infinity over infinity, infinity multiplied by infinity. Those cases, these are called indeterminate form of limits. So when we'll be putting in infinity, we shouldn't have such cases, infinity over infinity or infinity multiplied by infinity, or maybe negative infinity over negative infinity, or maybe negative infinity multiplied by negative infinity. These are basically called indeterminate form of limits. So every time you have something like that, do not give your solutions to be in that form. Those are called indeterminate forms of limits. So now, let's solve the first question. So what do we do to avoid these cases? That's the question. What do we do to avoid all these cases? So question number one there. Sorry, I might be a little bit fast. Yeah, I'm looking, I don't want to spend a lot of minutes in this video. I want it to be a little bit short, but you can be pausing as we go through so that you understand. Rewind, pause, so that you can be understanding through. So question number one, limit as x approaches infinity of 3x power 3 plus 2x over 4 minus 2x squared minus 7x power 3. So if I was to put in infinity everywhere, what is going to happen? If this is infinity, this is infinity, this is infinity, this is infinity, what am I going to have? I'll have something like infinity on top and infinity down. It will be more like an infinity over infinity. And we said that that should never be the case in terms of our solutions. So what do we do in such a case? We are going to say that every time you are solving limits to infinity, always factorize. So factorize the numerator or let me use the word factor. Let me say factor the numerator Chizungu, factor out the x with the highest power on both the numerator and the denominator. So the first concept is you factoring out the x with the highest power on both the numerator and the denominator. That's your first task to do. So if we do that, what am I going to have? I'm going to have that the limit as x approaches infinity. On the numerator here, x power 3 is the x with the highest power. So I'm going to have x power 3 factored outside, open bracket. If I factor out x power 3 outside, I'll remain with a 3 here. If I factor out x power 3 here, what is going to happen? Remember, when we factor something outside, it means every term is divided by this. So if I have, let me write something here. If I have 3x power 3 plus 2x, if I want to factor out x power 3 to be x power 3 outside, open bracket, 3x power 3 divided by x power 3 plus 2x over x power 3. This is what we mean by factoring out. So if I tell you to factor out, then we have x power 3 outside. The same x power 3 divides every term there. So that by the end of the night, this and this cancels out. We'll have x power 3, open bracket, 3 remaining, plus 1x and 1x goes here. We'll have 2 over x squared. This is what is going to happen. We are okay? So the same is happening here. If I factor out x power 3, there I'm going to remain with 3 plus 2 over x squared, closed. In the denominator here, x power 3 again is the highest power. So x power 3 will be factored out, open bracket, every term divided by x power 3 minus 2 over x. Why? Because it will be x squared over x power 3. The squared and the squared will cancel. No wonder we are remaining with a 2 over x power 3 minus, since x power 3 has been factored out, when you divide, we'll just remain with the 7. This is what I'm going to have. And then when we simplify, this is multiplication here, this is multiplication, this and this are common. It means that I'm going to remain with the limit as x approaches infinity of 3 plus 2 over x squared over 4 over x power 3 minus 2 over x power 3 minus a 7. Then let's put in infinity everywhere now. So remember those rules. If we have constant over x power n and we put in infinity, this becomes a 0. This becomes a 0. And this becomes a 0. Because we said that the limit as x approaches infinity of 1 c over x power n is always equals to 0. So here infinity here is 0, infinity here is 3, infinity here it's 0. So what am I going to have? It is 0 minus 7 here, which is negative 7, 3 plus 0, which is a 3. Automatically this is going to be equals to 3 over negative 7, which is the same as saying negative 3 over 7. This is the limit which we are looking for. As simple as that. So that's limits to infinity. Every time it's limit to infinity, factor your numerator, factor the denominator by factoring out x, which has the highest power, x, which has the highest power. We will simplify, then put in the infinity on all the things, all the terms, so that you can come out to be something like that. You don't put infinity x on infinity. Do it in your heart. Be professional. 2 over infinity, you know that it is 0. Remember, infinity represents a biggest number you can think of. So we have the second part. Let me delete this. Let's go to the second part. So the second part says find the limit as x approaches 4 of x minus 4 over root x minus 2. So this is to a point. This is not infinite. It is to a point. So if it is to a point, if I put it in there, I place everywhere where there is x to be 4, what am I going to have? I'm going to have 4 minus 4 over the root of 4 minus 2 to give me a 0 in the numerator. Root of 4 is 2. 2 minus 2 is basically a 0. We said that 0 over 0 should never be a what? Our solution. This is an indeterminate form of limit. Should not be your solution. So if it brings in a 0 over 0, what do? Simplify your function. We can simplify especially by factorizing or rationalizing. Simplify either by factorizing completely or rationalizing. So in this case, whichever you choose will still be okay. Someone would decide to factorize the numerator and then come and simplify, or someone would say rationalize the denominator, because in the denominator there is a radical. So whichever you choose is still okay. So I'm going to factorize. I can have the limit as x approaches 4, x minus 4 over root of x minus 2 can be equal to the limit as x approaches 4. Factorizing the numerator, here is a difference of 2 squares. So this is root x minus 2 root x plus 2. A difference of 2 squares. How do we factorize the difference of 2 squares? Square root x is root x. Square root 4 is 2. One is negative, the other one is positive. But in the denominator, we still have root x minus a 2. We factorize completely. Then simplify. So this goes and this goes. It means we're dealing with the limit as x approaches 4 of root x plus 2, which is the remaining, because this and this have cancelled out. So we're remaining with this. We can now punch in 4. Then we're going to have the root of 4 plus 2 to be equals to 2 plus 2, which is equals to a 4. And this is your limit. You have solved the equation without any challenges and any difficulties. Thank you very much. Let's see you in the next video.